Yes, please go ahead.
So, a very good afternoon to all of you. Today I'm presenting a presentation on sentiment-aware AI assistant integrated with augmented reality for enhanced human AI interaction. Myself, Amit Chauhan. Here are the content of my presentation: introduction, theoretical background and literature review, justification for research, and motivation and research gap, need for study, methodology, and then references. So basically, what we are doing, as we know that in the traditional sentiment analysis, we used to judge the polarity of a sentence whether the text is positive, negative, or neutral. So here, what we are doing, we are taking the AI assistants like Siri, Alexa, or Google Assistant. We are here analyzing the emotions or inputting in the AI assistants the human emotions with the help of augmented reality and AI. So here is the background. As we all know that there are two types of basically there are four types of sentiment analysis. So we are basically working on sentiment analysis with the two types are emotion aspect is uh, where two types of polarity in a single sentence. So here, so basically this is a literature review, a minor project report of the BTech, where we are the main challenges are latency, privacy, and cultural adaptability. So here is a literature review table. These are the authors and the journals. Title of the paper is Roberta, a robustly optimized BERT pre-training approach. Variables are transformer layers, pre-training datasets. The main gap is no AR integration into this. As we say in the next article, there is no multimodal fusion techniques have been used, and next in the AR specific data sets is not been specified here. So these are the all these knowledge gaps are has to be covered yet. So what we are trying to do, we are trying to implement into the into the real time assistants emotions with the help of AI and AR. So here are the motivations. Emotion intelligence critical for human-like AI communications. AR offer immersive visuals, but is emotion neutral. So the research gaps are no unified or real-time multimodal sentimental sentiments plus AR integration, a very limited cross-cultural emotion adaptability, few privacy first emotional AI deployments. So basically, this is just a review article. In the future, what we are going to do, we are going to implement double polarity in we are going to apply for the double polarity with the help of aspect based sentiment analysis into the assistants. So here are the problem statement and the objectives of the article. Existing AI and AR systems lack integrated emotional adaptability and limited user engagement. So here are the main research questions of our article. How do how to detect sentiment accurately across cultures and modalities? Like we have different type of modalities with us, like only text plus video, text plus acoustic plus visuals. So these are the three types of modalities we do have. Next is how to adapt AR visual dynamically to match detected emotions, how to achieve real-time performance on edge AR devices. Our main objective is to develop a sentiment aware AI and AR architecture and optimize the accuracy, the latency, and inclusivity, and embed the ethical and privacy to the safeguards. So here are the this is the benchmark which we are going to perform in the future, and we are also working on with multimodalities on textual and with the visual models also. So here is the need of the study: build trust through emotionally relevant responses, enhances user engagement by personalized AR experiences. Like we all do see in Google, in Siri, they are not. they cannot perform, they cannot judge whether the emotions are accurate or not. So that's why we have using this. Here are the applications: healthcare, mental health support by emotion aware, uh, augmented reality, then in education, then in retail. It supports global usability with multilingual emotion datasets. These are the datasets. And for aspect based sentiment analysis, there is a specific workshop conducted by semantic evaluation. So we are gonna use those datasets only for the semantic. So here is the methodology. How do we do the work? This is a workflow. Your user input module, then with the use the tokens, sentiment analysis module, AI processing layer, decision points, and the models, where we have AR headsets and smartphones. So here are the references. Thank you.
So, as a small introduction, the importance of clean rooms in the aerospace industry. I'm an aerospace engineering student, and we are using clean rooms. Clean rooms are required in the aerospace applications, specifically in satellite assembly and handling of electronic sensitive devices. They help to protect these delicate systems from contamination and electrostatic damage and electrostatic discharge. We are based on the international standards as control environments with regulated airborne particle concentration. Design, construction, and operation aim to prevent particle introduction, generation, and retention. Clean rooms are very important for the aerospace industry, but also the electronics industry. So it is very important to ensure compliance with the standards while improving operational efficiency. That's what our work does, and it tries to do. Integrates RFID, Internet of Things, and a mobile app that we developed for the clean room access and appliance control. We are using the regulatory standards ISO 4644 for security, traceability needs, and constraints. For workflow and safety, we are using already existent IDs that we have in our university. We use relays, MQTT, HTTP APIs, and many data layers to store all the things that we need. As you can see in this image, we need to control a lot of appliances inside a clean room. They are very important. For example, multimeters, power supplies, air conditioners, humidifiers. There are very, very important appliances that we need to take care of. That's why also our system is in charge of controlling the systems while taking a list of who enters and who leaves the room. That's very important for us. So as an outcome, we would have control access, auditable logs, remote appliance readiness, operational efficiency, scalability, and advanced analytics about who enters, who leaves, and appliance control inside a clean room. So for conceptual definitions, we are using IoT, we are using real-time operative systems, so we can control many devices at the same time, as well as the door, the lock, so we can enter or leave. We are using RFID technologies, so we can use our own uh, student IDs credentials. So it's easier for us to get into the clean room with our existing IDs. Well, as justification, they are, as I already explained, they are essential for aerospace tasks. We need an affordable and open source solution tailored to specialized environments. In the part of the research gap, few implementations combine access control, appliance management, and remote operation in clean rooms. The research question that we want to answer is how can IoT and RFID can be integrated to manage clean room access and appliance efficiently? And can such a system remain low cost and open source without compromising reliability? So we implemented already a prototype system using an ESP32 RFID module and a mobile app that we've developed using MIT App Creator. We want to evaluate its performance in meeting aerospace cleanroom operational needs. We already did that. We developed a nanosatellite in another project, and we used this project for the management of the cleanroom. It's very important to maintain an up-to-date activity register in aerospace
Siva,
cleanrooms. Yes,
sorry for the interruption. Can you show the
yes.
results?
Can you
Results
repeat?
from, can
Can
you
you?
show the results?
I don't understand. Can you repeat?
Can you go ahead and show your results, your findings?
Okay, yeah. Here, well, this is what we developed, the theoretical framework and the proposed conceptual framework. As in findings, we successfully developed a functional prototype. It's a small prototype with the ESP32, the RFID uh, module, some relays, some LEDs, uh, working as the appliances and the small lock. It worked perfectly. It We use the RTOS, real-time operative systems, for meeting the performance. We demonstrated that combining RFID with the IoT platforms supports compliance with strict aerospace standards. It worked for our project while developing a satellite. Here I have some images of what we did. This is the mobile app that we developed for the appliances. We have some lights, the extractor inside the clean room, an air cooler, and a humidifier. And also here we connected it with Google Apps Script, so we could have Google Sheets form filled with all the entries from the clean room, so we can know who entered at which time and the ID of that person. And this is our references. Thank you.